All right, let's try to finish up this, at least the first half of this lesson. And so we talked a little bit about trapezoids yesterday. We talked specifically about a particular type of trapezoid, not just any old general trapezoid, isosceles trapezoid. So isosceles trapezoid, by definition, has what? By definition? Well, any trapezoid has one set of parallel lines, okay? But what's specifically about an isosceles? What's true about? What makes it isosceles? Okay, yeah, you got two equal sides, okay? And it's the ones that are the non-parallel sides, okay? So the non-parallel sides are equal to each other in length if it's an isosceles trapezoid. We had a theorem that said something about the angles. So if I got two sides that are equal to each other on a trapezoid, what's true about the opposite angles? They're equal to each other, okay? And we talked about the diagonals. We said the diagonals of an isosceles trapezoid are what? Isosceles trapezoid. It was the last thing we talked about yesterday. What's true about the diagonals of an isosceles trapezoid? Look in your notes. Anybody take notes? Nobody? Nobody took notes yesterday? You should just be able to look back on it. That's your notes. What's true about the diagonals of an isosceles trapezoid? They're equal to each other. That doesn't quite look perfect, but that's close enough. All right, so here's an example. You should be writing this down. It's in the book, but you should be writing it down. So that means you shouldn't be talking. There's no reason to talk. You should be writing. This is example 2 in this section. A, B, C, D. A, B, C, D. And they tell you some stuff. What do they tell you? They tell you that angle, I'll write it down over here. So they tell you that angle ABC is equal to 125 degrees. They tell you that... Does anybody have the book open to example 2 on section 6.5? I'm pretty sure I wrote this down, right? So it says AC is equal to 7x, I believe. Just want to make sure that's right. And BD is 4x plus 12. And I think that's everything they tell you. All right, and they ask for you to find a whole bunch of stuff. Let's write down the stuff they ask you to find. They ask you to find angle BAD, that bad angle. That's 120. Oh, what am I doing? I'll just put equals. I guess when I wrote my notes, I put the answer there. Say angle B is actually asking for ADC, angle ADC. And part C, they're asking for angle ABD, ABD. Part D, angle ACD, ACD. Part E, asks for AED. Oops, let's write the angle symbol, AED. And then part F, they actually ask for a line segment, just AC. All right, there it is. This is what they give you. There's the picture. This is what they ask for. So where do we begin? What would you do? Just put it away and start crying? All right, AC. All right, so that whole thing right here, from here to there is 7x. ABC, angle ABC, which one's that one? ABC, it's that whole big angle B right there, isn't it? I'm just going to write it out here. Is that all right? We'll put equals 125 degrees. What else? BD, that's that whole thing right there, and it's what? 4x plus 12. Let's start there. There's only one question that it asks for a length, all right? So let's do that one first, okay? And then I'll erase it just so we get rid of a lot of the stuff on the picture. Why do you set them equal to each other? Exactly right. The question that I asked you earlier, I asked you about the diagonals of a trapezoid, didn't I? Of an isosceles trapezoid. And I think they tell you I don't know, in the book. Does anybody got the book open? I don't have it open to this page. Anybody have it open? You got books there. Open it up. Page 6.5. I asked you earlier. 6.5. Look at it. Example 2. Do they say this is isosceles trapezoid at the beginning? Nobody's opening up a book. Is anybody? Tristan is. What is it, Tristan? Section 6.5. I don't know what page it is. Does it say that this is a trapezoid? They probably start off saying trapezoid ABCD is my guess. I didn't put that in my notes. Isosceles. Okay, good. Yep. So they say it's an isosceles trapezoid. All right. So they do tell us it's an isosceles trapezoid. We would not be able to say that AC and BD are equal to each other unless we knew that it was a what? Isosceles trapezoid, okay? So if it's an isosceles trapezoid, that must mean that this one and this one are equal to each other. Now we can say the diagonals are equal to each other, all right? So we're actually doing part F first. It's the only one that has to deal with a line segment, all right? So we're trying to find the length of that diagonal. That's AC. So we set them equal to each other. It's pretty easy. So what do I got? Let's do this in white instead of red. So let's do it right here. Let's do it right here. So what? 7x equals what? 4x plus 12. Subtract 4x, we get 3x equals 12. Divide by 3. What's x?
X equals 4.
Is that my answer, though? Do I put 4 right there? No, I got to find AC. Very good. It's 7 times x. All right, so this is 7 times 4, which is 28. All right, so that's 1 down. Now I got 5 more to do. They all have to do with the angles, though. Since I'm done with that, let's just get rid of all this mess. Just kind of gets in the way, doesn't it? And that's good. We'll just keep that right there. All right, angle BAD. BAD. That's this angle right there. Well, how do I do that? That's right, because the base angles on an isosceles triangle, we talked about this when we talked about isosceles, or not triangles. What are they? It's not a triangle, it's a trapezoid, right? They both start with TR, and they both have a lot of similarities to each other. So on an isosceles trapezoid, the base angles are equal to each other. That means that big angle A and big angle B are equal to each other. Also, what else? Big angle D, what? Is equal to big angle C. Does that mean that angle D and angle A are the same? No. It just means D and C are the same, A and B are the same. So without any math whatsoever, what's angle A? It's 125. So that's 125. All right, because this one and this one are the same. All right. Did they give you anything else? Yeah, they do, and I didn't write it down. I was going to say, I don't know how to solve for the other angles because they got to tell you something else. I believe they tell you this is 30 degrees. Is that right? Tristan, you got the book open? Yeah. I think they tell you that one's 30. Is that right? Yeah. Okay. So let's think a little bit. Let me ask you this. What do I know about big angle A and big angle D? They add up to 180. Does that help you? Because this is 125, right? So I could find what? That big angle D. Do I have big angle D? Which one of these is big angle D? ADC. Everybody see that? All right, so ADC, that's big angle D. So how can I find that whole entire angle right there? That's right. Well, I already know this is 120. I don't have to add anything, right? So this is 125. Remember, this is a trapezoid, so what's true about this and this? They're parallel to each other. This is a transversal. These are consecutive interior angles, right? Why would I do that? Look, I got this big angle right here, and I got this big angle right here. What do they add up to be? 180. 180. So what do I do? 180 minus 125. All right? So I'm taking this angle here, this angle here. They're supplementary. I know one of them, right? Every time we know that two things add up to 180, and I know one of those angles, how do I find the other one? I take it away from what? 180. All right? And what's that? 55? All right, so the whole big angle is 55. Okay, not this little one right here. This whole big angle is 55 degrees. That's what they ask for right here, isn't it? So that's 55. All right. Everybody good? I tell you what, while we're on it right now, let's find this little angle right here. That one. How would I find that? This one right here. I don't even know if they ask for it, do they? What? This would be 30. Yes, 55 minus 30. Very good. Okay, since this one's 30, the whole thing's 55. This would be what? But they don't even ask for that angle, though, I don't think, do they? ADB. Do I have an ADB here? Stop. Put it away. It's done. Put it away. Don't need you touching it. Don't need any noise from it. I don't know why you think that's acceptable. But they could have asked that, couldn't they? All right? They don't. But I just figured, I don't know. We might use it somewhere. Maybe we do. I don't know. Yeah. For D, I already got the whole big angle D. Oh, letter D. Gotcha. ACD. A. You sure about that? No, you're not going to use that 25 for ACD. Let's go in order. Let's do ABD. ABD. So this little one right here. Tell you what, let's do this a different color. Because I don't want to have to write like 3 arc things and 4 arc things. I'll just go yellow. So what about that yellow one? That's ABD. That's part C. What's that? Without any math, you can figure it out. I'll give you a hint. Why 30? Very good. I like that. They're alternate interior angles, okay? These are same side interior, or not same. That's what I used to use in my other book. These are consecutive interior angles, right? The 125 and the 55. But this yellow one is the same as, we'll put that in yellow. That one right there. You see it? There are 2 parallel lines cut by transversal, and they are what? Alternate interior angles. What do we know about alternate interior angles? They're equal to each other. So if this one right here is 30 degrees, what's this one up here? That's 30 degrees. All right, and that's what this is. We good? What else? ACD, where's that? ACD, let's go different color again. Let's go blue. So ACD is that angle right there. Not ACDC, but ACD. That one right there. That's easy. It's 30, that's right. Why is it 30? Yeah, because I see that they're 30. I'm just trying to give a good explanation. I want to back it up with reasons that I know. They definitely are. I'm trying to think of a good reason why they're 30. Let me see. If anybody can give me a good reason, besides they just look like they would be the same. And it is 30. So I'm not doubting that. I'm just trying to find a good reason. Let me do this. This one? It is an isosceles triangle. And again, I'm trying to think of why. Because it's not being bisected, but well, that's true. The base angles of an isosceles triangle are equal to each other. That is absolutely true. Okay, but how do I know that this and this are equal, though? To actually find the answer, it's not hard. I can see that's 30, and I know that's 30, right? It looks like that's an isosceles triangle, but I keep saying it looks like. I know that it should be. I don't like that. I like to back it up with reasons that we've learned before. Why is this 30 when this is 30? Alternate interior angles. How did we know to subtract from 180? Because they're consecutive interior angles, right? And they're supplementary. So I need good reasons to back it up. And to tell you the truth, I'm kind of not seeing a good reason. There's got to be another way. Let's see. That's 55. There's got to be some other. Oh, I could find. Have I done the 125 yet? Oh, the 125 is it the whole thing? The 125? Okay. So, I don't know, will that help us? That whole thing, right? Yeah, from there to there, that whole thing is 125. That's 30, so what's that?
95.
95? Is that going to help us? I don't know. Well, if that's 90, well, let's see. Boom.
What if we go to the next question?
Let's do parallel lines cut by transversal. Parallel lines cut by transversal. That's 30. That's 30. Well, see, in my notes, I didn't give any explanation. I just wrote down what the answer is, and I should be able to see it. What am I missing? I'm missing something, aren't I? Somebody look. Kate, you see it? Give me a reason why that's 30 degrees. How do we know it's an isosceles triangle? Yeah. Well, it's true. Those diagonals are equal to each other, but we never had anything that said about they intersect in the same spot, like you said, or that this are equal. But right. Yeah, but common sense always has a reason why you do something, and that's especially in geometry. And you're right. I mean, when I look at this, it is kind of like common sense, but they don't bisect each other. They don't bisect each other. And it is true. It is kind of common sense, and I get what you're saying. But as a geometry teacher, we need to back up everything that we say with a reason. Right, but the thing is, how do we know it's an isosceles triangle? What, this side right here and this side? Okay, well, let's use that. If these, then what's true? Okay, watch. Oh, I think I have it. Watch this. That's 25 as well, isn't it? Because I know the base angles are equal, right? So I know that whole thing is 55. If I know that's 30, I know that's 30. So this has got to be 25 because I take it away from 55. And then watch this. So these two triangles, watch this. Everybody watching? Don't talk. This triangle's got angle, side, angle. And this triangle has what? See, if I took that away from that, that would be 95 as well for the same reason we did all that stuff. So I would have angle, side, angle. Everybody see that? So these two triangles are congruent. That means that what's true about this? That means that this side and this side are equal to each other because they're corresponding parts of congruent triangles. If I took those two triangles, put them on top of each other, they would both match up, wouldn't they? All right, so they would be equal to each other. So there we go. There's our isosceles triangle. Now that we know that this is an isosceles triangle, now I can say that this angle and this angle are equal to each other. Therefore, that's 30 degrees. All right, so there's my reason. I don't know. Don't worry about it. Let's just worry about how to do this, okay? So everybody got that? That was my issue. Well, it's not my issue. It's every geometry teacher's issue. We always got to back up what we say. We can't just look at it and say, well, it sure looks like it's an isosceles triangle. We have to have a good reason why it's an isosceles triangle, all right? Whether that shows up in your answer or not, that's just me as a geometry teacher. I have to know why. All right, so again, that might be my issue, but let's keep going. We're almost done. One more. AED. So there's this is E in the middle. I forgot to put that. So AED, so that's this one right there, that green one. So what is that? Well, that would be the same as this, wouldn't it? And so this is 95 and that's 25. What's 95 and 25? 100, 120, right? Yes? Yeah. So that's 120. Take that away from 180. What's that? 60. So what's this angle? That's 60, and that's 60 right there. Is that what they're asking for? Yep. AED. That's 60, and that's 60. There we go. This one, because of this triangle right here. See this triangle? EBC. So I knew this was 95, right? I knew this was 25. Altogether, that's 120. Take that away from 180. That gives me my angle right here. Okay, so 180 minus 120 is 60. If this is 60, this is 60, right? Because they're oh my gosh. How do I forget that? What's the word? They are congruent, but there's a name for it. Oh my gosh. I say this all the time. Vertical angles. Thank you very much. They're vertical angles. Man, when I teach geometry, I say that so many times. So they're vertical angles, so that must be 60 as well, since that's 60. Okay? All right. I hope if you gain one thing, I hope you gain maybe, I don't know if you did or not, but maybe an appreciation for always having to back up why things are equal to each other. All right? Because I could have got that to be 30 just looking at it, say, well, that's 30. This is probably 32 because it's probably a isosceles triangle. But probably is not good in geometry. All right, you got to know for a fact. And yeah, we know for a fact that that's 30 degrees. We talked about it. We know that's 60 because we talked about it. On we go. Okay, enough of that. Make sense? All right, let's do another thing. No, you can't. All right, let's do another trapezoid. This is not an isosceles trapezoid. I mean, it could be, but it doesn't have to be. I'll say that much. Everybody hearing me? So this is not an isosceles trapezoid, but it could be, but it's not. So what I'm going to do is I'm going to find the midpoint of both of those legs right there. So if I highlight that, the midpoint is right there. If I click off of it and then put a dot, that should be pretty close to the midpoint of that side, or that leg. And then come over here, and then that should be the midpoint of that leg. All right, see what I did so far? Just found the midpoint of those two legs. Guess what I'm going to do with those two midpoints? Guess. Talk to me. Going to connect them. Very good. Okay, going to connect them. All right, it's pretty close. It's off just a tad, but it's pretty close. All right, so let's put some letters in here. We'll use A, B. We'll use C, D. We'll use M and N for this. Okay, everybody with me? Now, what we're going to do is we're going to learn a theorem that has two parts to it. It's got two parts. First of all, we knew it was a trapezoid to begin with. So ABCD was a trapezoid. So what do I know about AB and DC? They're parallel to each other. Just because it's a trapezoid, right? You got to have you have to have exactly one pair of parallel sides. So those are my parallel sides. They're parallel to each other. Here's what the first thing of my theorem says. All right, it's called the trapezoid. By the way, we call this thing right there, we call that the midsegment. I think we've done that before of a triangle, haven't we? Remember I said there's a lot of easy words so quick. Similarities. A lot of similarities to a triangle and a trapezoid. Because remember, what is a trapezoid? Trapezoid is basically a triangle, but I cut it off, right, parallel to the base. Isn't that what a trapezoid basically is? Yeah. So there's a lot of similarities. So it also has a midsegment, and we've talked about that before. Okay, when we did a triangle, what did we say about that midsegment? It was what? It was parallel to the base. Well, this one has more than one base. It's got, what did I write it? It's got one base here. What do I call AB? That's a base as well. So a trapezoid has two bases, so the parallel sides are the bases. All right. So if the bases are parallel, what's true about the midsegment with the bases? What do you think? It's parallel. That's right. We've talked about this with a triangle, very similar to the triangle. Now, here's something that's kind of crazy. I think we said this on the triangle, that mid-segment, we said the mid-segment was how much of the base. Do you remember that? We didn't do a lot of that, but I think we did it. The mid-segment on a triangle is half of the base. Half of the base, all right? This is kind of, right? See, with my hand, I'm going maybe a little bit. It's kind of the same. So this is not half of this, and it's not half of this. But guess what? It is half of, what do you think? What whole thing?
Top to bottom.
Like both of them combined.
Which, both of them? What's them? Okay. Yeah, just call it B1 and B2 since I made it easy for you. Okay, but you're absolutely right. Okay. It's half of the combination of the two bases if I add up the two bases. It's basically the average. If I gave you two numbers and I asked you to find the average of those two numbers, what math would you do? You'd take those two numbers and do what to it first? Add them up, and then you would divide by 2. Everybody with me? So the mid-segment, there's two things that's true about it. One, B1 would be parallel to B2. So the bases are parallel to each other. You know that. That wasn't hard to figure out. This second one might be a little tricky to figure out. But it's very similar to the triangle. All right? So it's basically the average of the two bases. All right? So the mid-segment, MN, all right, is equal to what? What if these were numbers? B1 and B2 were numbers. What would I do? I'd go B what? B1 plus B2, and then do what to it? Divided by 2. All right? It's basically the average. The mid-segment is kind of like the average of the bases. Everybody got that? Let's stick some numbers in here. Now, they draw a different picture in the book. I'm just going to keep the same picture, but I'll call this one. I'll call that one 2R. It's kind of weird they put an R in there, but you've done that before, right? You've done with X and that kind of stuff. So we'll call that 2R or 2X if you wanted to. They call this mid-segment 10, and they call that other base 4R plus 2. I guess they got tired of using X, so they used R. All right? So we have to find what, I want to find the length of AB and the length of DC. That's what I'm trying to find. So before I even think about finding the lengths of those two, what do you think I'm going to solve for first? Solve for R, that's right. Just like we always have, right? We always solve for X. We always call it X. This time they decided to call it R. Okay? You with me? Okay. So how do I find it? How do I find R? Well, look at this thing right here. It says MN, or the mid-segment, right? The mid-segment is equal to the sum of the bases divided by 2. Well, what do we know? That's right. So instead of mid-segment, what am I going to put? Put a 10 equals what? What are my two bases? Yeah, I got one of them is 4R plus 2. And what do I do to the other one? Yeah, plus. Good. 2R. I add them up. And then what do I do to it? Divide it by 2. See how I set it up? So I took the mid-segment. This time they tell you what the mid-segment is. All right? They don't ask for it. They could have very easily. Watch. What if they would have said this was 3 and this was 5? What would the mid-segment be? It'd be 3 plus 5, which is what? 8 divided by 2, which is 4. Okay? They don't make it that easy. All right? They could have, but they don't. All right? They actually give you the mid-segment. All right? And you got to find what the two bases are. You got it? Let's do the math. We'll just kind of push this over here. So 10 equals, what do we have here? 4R plus 2R. That's 6R plus 2, what? Divided by 2. You can do this a couple ways now. Okay, your algebra, you could do this a couple ways. You could divide everything here by 2, but here's what I would do. If it was me, I would multiply both sides by 2. Why would I do that? Why would I multiply by a 2? Yeah, I want to get rid of what it's being divided by. Exactly. Okay, I want to get rid of that fraction, right? So I multiply by 2. I can't just do that to the right side. Talk to me. I have to do it to the left side as well. So I multiply that by 2. What do I get? 20 equals, what happens here? Those two cancel. What do I have? 6r plus 2. Now it's super easy. Subtract 2 from both sides. That's 18 equals 6r. Divide by 6. What's r?
3.
Yep. Is that my answer, though? No, because they asked me to find the bases. So what did I say r was? 3? So we'll write it up here. So r is 3. See what I did? All right? This is the geometry right here. That's your geometry. You turn it into an algebra equation. We've done this dozens of times this year, haven't we? All right, so here's your geometry, and now it's just all algebra, and you just get r by itself. And now I can find, let's do it in a different color. Now I can find what the top and bottom is. So top's easy. It's 2 times r. What did I say r was? 3. So what's the top? 6. Okay, what's the bottom? 4 times what? 3, which is 12, okay, plus 2, which is 14. I want you to see something. Remember, the mid-segment is like the average. It's in between, isn't it? So how far is it? How many numbers between 6 and 10? 4, right? So how many numbers is it going to be between 10 and the other side? 4. You see it? So that works out perfectly, doesn't it? Right? It's right in the middle, if you want to call it that. Mid-segment, middle, right? Mid. All right, so it's right in the middle of those two. What do you think? You good? Yeah, that's not too hard. This is kind of a nice, easy one. They actually gave you the example a little bit harder than they normally do. Normally, they would just put numbers in here, right? And then they would wait till a problem in the homework until they start putting some letters in there and that kind of thing. But they did it right off the bat, right with the example. You should be good to go now. All right, that's enough of that. So let's see. Did I split this up into A and B for the homeworks? I did. So it looks like A is 1 through 12. So it's section, what is it, 6.5? So 6.5A. And it's page 280. I'll write down the page, 280. And it is 1 through 12. That should, I believe, not 100% sure, but I believe I just gave you stuff with trapezoids. Okay, if there's stuff with kites in here, then don't worry about it. Okay, we haven't done the kite yet. But I'm pretty sure that all this stuff is just trapezoids. Everybody got that? Did you already try it? Or you already looked at it?
Oh, no.
Oh, okay.
I thought I looked at the lesson plan and thought that, because I was looking at Wednesday and I thought that would be like number 12.
Yeah, we're actually right on track this week. Okay, every day, all 3 days we've had this week. It's got what? A kite, 9 through 12? Okay, well then just do 1 through 8 then. 1 through 8. So 9, 10, 11, and 12 are all kites? Okay, just do 1 through 8. All right, we'll save the kites for the next one for part B, because I haven't taught that yet. Everybody good? When's this over? 10 till? 50?
Got 7 minutes.
Where am I? Yep. All right, you got 5 minutes. Now look, let me see that you guys can actually do this. My senior class, we had 5 minutes left. We just finished an example, and they had problems in the homework to do that looked exactly like we just got done doing. Look, this is fresh in your mind right now. It's fresh in your brain, all right? You got 5 minutes. That doesn't mean that, listen. A lot of people, their mindset is, oh, we only have 5 minutes left, so I'm not going to do anything. But I like to look at it as, hey, we still got 5 minutes left. Let's get a little bit done, all right? That should be your mentality. So let's do it. You got 5 minutes. It's not time to pack up and put everything away. Get the book out. You got 5 minutes to do a few of these problems, all right? You only have 8 to do. I bet you could do probably half of them by the time you leave here, all right? And then you barely got anything left. All right, so let's do it right now. Let's work. This is not free time. This is time to work on the homework. So let's do it.